Okay, so here it says let part T says let A be equal to 3k, B equals to k. Find in terms of k the maximum length of a painting that can be removed from the gallery through this doorway. Um, so again, they're asking you kind of for the same thing. They asked for the max length of the painting. The max length of the painting will correspond to the min of L. Okay, so that's kind of weird, but so that was, we needed to do some thinking to kind of arrive at that. And so what they're asking you to do is minimize L for these specific values of A and B. Okay. And earlier we did exactly that. Well, not that, but we found the derivative. Okay, so this is from part C earlier. And we can use this information because all we need to do is optimize, find the minimum of this, and we can do that by setting the derivative equal to 0 and solving. Okay, so I'm going to do that. I'm going to set the derivative equal to 0. That'll give us the stationary points. Stationary points are not guaranteed to be minimums in this case, but you can always do a sign chart to confirm that you are getting a minimum. Before I do anything else, though, I think what I want to do is combine these two fractions together. So I'll multiply the top and bottom by cosine squared here, multiply the top and bottom by sine squared here. Okay, so it's going to be negative 3k cosine cubed alpha plus k times sine cubed alpha. That's all going to be divided by sine squared alpha cosine squared alpha. This expression on the right is going to be equal to 0 when the numerator is equal to 0. So we can simplify that to this. And then what we can do here is, by the way, this is just a kind of general trick, but anytime you have like a sum and you have a sum of cosine and sine as trigonometric functions and they have the same power, the strategy is always the same. Just divide through by cosine cubed, because when you divide through by cosine cubed, what's going to happen is you are going to turn this into a single trigonometric function. Okay, so instead of being a function of sine and cosine alpha, it's just going to be a function of tan alpha, and that's convenient because it makes it easier to solve. On the left, we get 0. We get negative 3k plus tan cubed alpha times k. Okay. Now here, just make a note here that cosine alpha cannot be 0 because we divided through by it. Okay. What we could do is add 3k to both sides and then divide by k. And then you'll get, that's tan cubed. And 3k divided by k, as long as k is non-zero, and k is going to be non-zero. By the way, k, because it kind of represents the width of, here k is related to the width and the A and B values, and because it's related to the A and B values, it kind of represents the width of the corridor and the art gallery. So k is going to be positive, just as A and B are positive constants. Okay, so k is a positive constant. So because k is a positive constant, it's safe to divide through by k here. It's fine. Okay, and so tan cubed alpha is 3. If you cube root both sides, you get tan alpha is the cube root of 3, and alpha is going to be tan inverse of the cube root of 3. Okay, that's the exact solution. Because this is a paper 2 exam, honestly, at this stage, if you like, you could just try and use and solve or graph or something and try and solve that way, and that would be fine. The question doesn't say it needs an exact value, at least I don't think. Yeah, it doesn't say anything about an exact value, so I think it's fine. This here represents when the minimum happens. Okay, so what we want is the actual minimum value. So we can say, therefore, min length or min L value is going to be approximately equal to. Okay, so I had to. So this is the value of alpha that makes L a minimum and corresponds to a max painting length. But I had to find the formula for L, and this was from earlier. What we can do here is you could leave an exact form, but it might be easier just to approximate an answer. From this formula, we can pull out a k And if we pull out a k, we get something like this. We get we get 3 divided by sine alpha plus 1 divided by cosine alpha. And because we have a value for alpha here, we could just take that value and plug it into here and here using a GDC. So all I did was I took this alpha value, I think it's approximately 0.965 or so. I took this alpha value approximately and just put this into here and here. And then I evaluated this expression, and I got about 5.41 to 3 significant figures. And then that needs to multiply by k. So we get about 5.41 k. And that's your min L. And therefore, the max painting length is 5.41 k in terms of k. Okay, because the question says find the max painting length. And it says to find it in terms of k. So that's our final answer. Okay. Hopefully that was helpful. I've never made video solutions to formatives and summatives, but I think for this one, because of how difficult it was, I thought it was appropriate. If you find these helpful, just let me know. Maybe in the comments below or something, and I can try and make more videos like this, like going into DP2. Okay. Even if we do go instead of online, if we're in person, I can still take the time to make these if they are helpful. Okay, have a wonderful rest of your weekend. Study hard for the summative. I'll be posting additional Section B practice, past paper Section B practice questions on ManageBac once you finish the review. Okay, bye-bye.